All right, Honors Chem, today we are going to learn about neutralization reactions. Okay, so neutralization means that I'm taking an acid and a base and I'm mixing them together to neutralize both of them. So simply, you've got an acid, so hydronium, which is basically, we could make it a generic acid like HA, hydronium H3O. That's water with an extra hydrogen on it, right there. That hydrogen is going to join the hydroxide. We could have a basic, any generic base. And if I react those, notice if that hydrogen goes onto the hydroxide, I have two waters. I have one here and one here. Water is neutral. So if I do a base and an acid together, these are double replacement or double displacement reactions. So H getting together with OH makes water, right? So I have liquid water, and then I will create an ionic salt. So this will be an ionic compound or an ionic salt. Okay, so when I put an acid and a base together, I make water and salt, some kind of ionic salt. Okay, so we're going to learn how to figure out how the net ionic equations are on these, and then in a next video, we are going to learn how to actually do the math behind some of these with quantitative neutralization. So let's work on the ionic equations first. Okay, so if I have hydrochloric acid here, which is a strong acid, right? So it means it dissociates 100%. So I'm going to have hydrogen and chloride ions in solution because it ionizes and dissociates 100%. I have sodium hydroxide, which is also a very strong base. It's also going to ionize or dissociate 100%. Okay? And then on the opposite side, I have sodium chloride, which this is soluble. So because it is soluble, you might want to look at your solubility charts. It's also going to be individual ions. And water, liquid, we know that that doesn't dissociate very well. The dissociation constant for water is 1 times 10 to the negative 14. So it's going to actually stay together a lot more than it dissociates. So we're going to have liquid water. So just like we did net ionic equations when we did our solubility rules, anything that is on both sides of the equation in the same quantities, we can cancel out. So let's look at some of the things that we can cancel out here. So I'm going to change my color. So let's see, the chlorides repeat and the sodiums repeat. So what I have left are the hydrogens, the hydroxide, and the water. So my net ionic equation is what's just making water, okay? Because in reality, the sodium and the chloride ions don't participate because they're soluble, okay? Recall that in an aqueous solution, hydrogen ions really exist as hydronium ions. They are piggybacking on those water ions. So the net ionic equation for an acid neutralization really is hydronium plus hydroxide making 2 waters, okay? Now, because we are lazy, we normally don't write it out as the hydronium ion. We usually just write it out like this as the hydrogen ion. But in reality, this is what is happening in reality. Okay? So let's complete the following reactions. Now, in order to complete the following reactions, we need to remember a few things. We need to remember our strong versus our weak acids and bases. So we need our strong acids and bases. And we also need to remember our solubility rules. Okay, so if you need to tab those pages where those are listed, go right ahead, take a minute to tab those so that you can flip back and forth. We're going to just start in on this. Okay, so we've got potassium hydroxide reacting with hydrobromic acid. Now, let's just do double displacement. Remember, all of these are double displacement or double replacement reactions. So potassium is going to get together with the bromide. Potassium is a positive one, bromide is a negative one. So I just need a 1-to-1 ratio here. So potassium bromide. Now, is that soluble? Yeah, it is. It's a group 1, so it's totally soluble. And then hydrogen getting together with hydroxide will make me water. And water is always in the liquid state. Now, notice that these are aqueous, this is aqueous, but that is liquid. So anything that is aqueous, we're going to break apart into the ions, and anything that is either liquid or solid, we are going to keep together. Okay, so let me change my color here. So I have potassium, aqueous, and the hydroxide ion, aqueous, plus my hydrogen ion, aqueous, plus my bromide ion, aqueous, getting together with my potassium ion, aqueous, and the bromide ion, aqueous, and then water sticking together as a liquid. Okay? So my net ionics, what are my repeaters? What can I cancel out? I can cancel out my potassiums, and I can cancel out my bromides. Okay? So what's left is my hydrogen ion getting together with my hydroxide ion to make me water. That is going to be my net ionic equation. Okay? All right. Let's look at this next one. I've got potassium hydroxide, which is a strong, let's change my color again. This is a strong, that's a strong base, but this is a weak, nitrous acid is a weak acid, so it's actually going to stick together. Okay? Now let's complete the prediction, double replacement. Okay, so +1 for the potassium, -1 for the nitrite. So potassium nitrate. Is that soluble? It is, because potassium, not nitrate, nitrite, sorry. I'm so used to drawing a 3 instead of a 2 there. This is 2. Okay, that is soluble because it is a group 1 ion. Okay, and then I'm going to make water. And that is going to be liquid because it actually sticks together. Okay, remember, weak acids and weak bases actually stick together. So even though they're AQ, they don't dissociate very well. So we're going to keep them together. Okay, so potassium is going to be off by itself. We're going to have a hydroxide off by itself. And I should put in the aqueous. But nitrous acid is going to stick together because it is weak. Okay? And then potassium is going to be off by itself. Nitrate is going to be off by itself. And water is going to stick together. Okay? Now, what are the things that repeat? There aren't a whole lot of repeaters here, are there? The only thing that really repeats is the potassium. So our net ionic reaction here, we're going to have our hydroxide ion getting together with the nitrous acid and making nitrite ion plus water. Okay, so notice a couple things. Notice our equation is balanced in terms of elements on both sides and the number of elements on both sides. It's also balanced in terms of the charges. I have a -1 here and I have a -1. So when we balance net ionic equations, charges on both sides of the reaction arrow and elements and numbers have to be balanced. Okay? Charges, elements, and amounts on all of them. Okay? So notice, because I have a weak acid here paired with a strong base, this is going to make me a basic equilibrium. And in reality, that reaction arrow is not going to be one way because I have that weak acid. It is going to be both ways. I'm going to have an equilibrium going on between this. Okay? Now, if you feel like you have it, go ahead and work on the next couple, and you can check in just a minute. Okay? So, here we go. We've got ammonium hydroxide. Ammonium hydroxide is a weak base. Okay, so that's going to stick together. And nitric acid is a strong acid. Okay, so that's going to break apart. We're going to do a double displacement. So ammonium is going to get together with nitrate. So ammonium is a positive one, nitrate is a negative one, so 1 to 1. Now this is soluble. All ammoniums and all nitrates are soluble, no exceptions. So that is soluble. And then hydrogen is going to get together with the hydroxide, 1-to-1 relationship there to make water. Okay? Now remember, weak acids and weak bases actually stick together. So we are going to keep this stuck together. Okay? So my ammonium nitrate or my ammonium hydroxide is going to stay together. My nitric acid, though, because it is strong, is going to dissociate and ionize. And my ammonium nitrate, because it is a soluble salt, is going to dissociate and ionize, or I should say dissociate. But water is going to stay together. Okay? So what are the repeaters that we have? Not a whole lot, are there? The only thing that I can really cancel out is my nitrate group. Okay? So my net ionic reaction, I'm going to have my ammonium hydroxide with my hydrogen ion. And because this is a weak base, it's going to really be an equilibrium going back and forth, giving me the ammonium ion and water. Okay, once again, my charges balance. I have a positive 1 right here, and I have a positive 1 right here. And my types and numbers of things also balance. Okay, so weak base with a strong acid, I'm going to have an acidic solution here. How'd you do on that one? Okay, here we go. Potassium hydroxide with sulfuric acid. The first thing to determine is strength of the acids and bases. Now, is potassium hydroxide strong or weak? It is strong. Okay, and sulfuric acid is also strong. Okay, so they are both going to dissociate 100%. Okay, so double displacement, potassium getting together with sulfate. Now, potassium is a positive 1. Sulfate is a negative 2. So because potassium is a positive 1, I'm going to actually need 2 potassiums to balance out that charge, to make that salt. Now, is that salt soluble? Yes, potassium is a group 1 salt. So, because it's a group 1, this is soluble. Okay, and my computer wants to think a little bit. So, also, because we had to put 2 potassiums in there, we're going to have to go back and we're going to have to put a coefficient of 2 in front of my potassium hydroxides once my computer finishes thinking and I can start writing again. Sorry, the computer's taking a while. It's been really glitchy lately. Okay, so we're going to need to put a 2 here, and that is soluble, so we're going to also need to put an AQ by here once it lets me. Okay, so I now have 2 hydroxides reacting with the 2 hydrogens. So that's going to net me 2 waters in the liquid state. Okay, now soluble, these are both strong, so they're going to dissociate 100% of the time. So let's write them dissociated. So I'm going to have 2 potassiums and 2 hydroxides and 2 hydrogens and a sulfate group. And 2 potassiums and a sulfate group with 2 waters. Okay, so we can cancel out the repeaters. So what are the repeaters? My potassiums and my sulfate group, those are repeaters, right? So I have 2 hydrogens with 2 hydroxides, making me 2 waters. Now notice, are these the lowest coefficients that I can possibly have? They are not. I have 2, 2, and 2. They all have a common factor of 2. So I can get rid of the 2 in all of these. So in reality, I should just be writing hydrogen with hydroxide making water. Okay? So that is how we determine net ionic equations with acids and bases, whether they're weak or strong, and how we determine what the net ions are that are really part of that ionic equation and that equilibrium. Okay, next video, we are going to learn how to do quantitative neutralization. So these neutralization reactions with stoichiometry. All right, so see you next time. Have a great time. Bye.